Today let's learn about the principle of high performance liquid chromatography. Now as you can see in this picture, there's a column and the column has silica gel embedded in it. And you can see in the start there is a mixture of compound, and what happens is as the sample is injected onto the column along with the mobile phase, you can see there is separation of bands, color bands, as and when they are reaching towards the detector. Now remember this thing, that the stationary phase here, there are two phases present in an HPLC. One is stationary phase and another is mobile phase. Now in an HPLC, the stationary phase is the silica column. That is a stainless steel column that is coated with silica material with it. And the mobile phase here is an aqueous or organic phase. It could be ACN, acetonitrile, it could be methanol, it could be any kind of buffer, or water could be used. So this is your mobile phase. Now as the injection happens, the sample is injected onto the column. There is continuous flow of mobile phase as well. And depending on the polarity of the analyte, there is separation of bands as and when they are reaching the detector. Now let's try to understand the principle of HPLC with help of this pictorial diagram. Now this is a polar column on the screen. The columns can be of two types in HPLC. It could be a non-polar column and a polar column. So if the column is polar in nature, that means that the silica material inside it has affinity towards water. So as you can see here, there's mixture of analyte in the start of the column. And along with the mobile phase in the second diagram, you can see that it has been separated. These bands have been separated. The circles, triangle and square has been separating. Now this separation happens because of the polarity of the analyte. You can see that the circles have been pushed towards the detector at a faster rate as compared to the triangles and the square. Now I told you that the column is polar in nature. So what happens here is, if the analyte is also polar in nature, it will interact more with the column as compared to the non-polar analytes. Non-polar analytes won't have affinity towards the polar column. It would have more affinity towards the mobile phase. If remember, when the uh, column that is used is polar, the mobile phase that could be used is the mixture of non-polar and mid-polar range. So the non-polar analytes, that is circles, it has affinity towards mobile phase more as compared to the column. So it's eluting towards the detector at a faster rate as compared to the mid-polar analytes and polar analytes. So non-polar analytes are the first one to get eluted from the column. And the mid-polar is following the non-polar analytes. And later, as the mobile phase gradients changes, what happens is the mobile phase would have more affinity towards the column, so as to replace the interaction of the polar analytes and the polar column, so that the last analyte is also eluted from the column. So this is the principle of HPLC. This is the working of HPLC. This is how the uh, mixture of sample is separated depending on its polarity. So depending on the analyte polarity and the column polarity, you can say there is separation of the mixture of the sample. Now in HPLC there are two types of columns. One is called as normal phase column, another is called as reverse phase column. Now normal phase column is nothing but a polar column. Now as you all know, the material that is used inside a stainless steel column is silica. Now originally silica is polar in nature. So if while the analysis you are using a polar column, that technique is called normal phase chromatography because the silica that is present in the column, it is polar in nature. So that is called normal phase chromatography. So example of normal phase columns are silica columns, cyano columns, amino columns, diol columns. Now what happened is silica was originally polar in nature, and because of that what was happening is the illusion of polar analytes was taking a long times to elute from that column. So what scientists did was it uh, changed the nature of silica by attaching carbon chain to it. So they attached C18 carbon to silica, or C8 carbon or C4 carbons. So what happened is because of that, this silica which was polar in nature was turned now non-polar because of that carbon chain. So that is called as reverse phase column. So these reverse phase columns nature is non-polar. So this was done because the illusion of polar analytes was taking longer run time. It was taking 1 hour, it was taking 30 minutes to finish one cycle of that analysis. So just to make a shorter run time of illusion of that polar analyte, they changed the nature of the silica by attaching 8 carbon to it, or 18 carbon to it, or attaching phenyl to silica. Uh, so that is how they made it non-polar in nature. So in HPLC analysis, you all can use two types of columns depending on your analysis. Now in normal phase chromatography or reverse phase chromatography, what kind of mobile phase can be used? Let's see what kind of mobile phase can be used in reverse phase chromatography. Uh, in reverse phase application, water is usually the base solvent because the nature of the column is non-polar in nature in reverse phase chromatography. That is why polar solvents are used and mid-polar solvents can be used. So polar solvents are water, and mid-polar solvents like methanol, ACN or tetrahydrofuran can be used. And in normal phase chromatography, where your column is polar in nature, so the combination of hexane, heptane, isooctane, ethyl acetate, chloroform, these mobile phase can be used. So just to summarize the principle of HPLC, let's see the diagram here. So there is stream of mobile phase. The stream of mobile phase is this way. And this circular things you all can see, it is nothing but silica gel. The column is filled with porous silica material. And this mixture of analyte, there is component A that is in triangle and component B that is square. So there is mixture of A and B component that has been injected onto the column. Now component A is eluted earlier into the stream of mobile phase as compared to component B. The component B, you can see it is interacting with the silica in the column. So what we can conclude here is that the triangle, that is component A, it has more affinity towards mobile phase as compared to the stationary phase, that is your silica gel. So you all can say that the stationary phase is here is polar, but the component A, because it is non-polar in nature, so it has more affinity towards mobile phase, and that is why it's eluting at a faster rate as compared to the component B. And component B, because it has more affinity towards the stationary phase, it is interacting with silica gel, and later as the gradient of the mobile phase is changing, then later it will be eluted from the column. So this is how the HPLC works. The separation of the components happen.